Hello, thank you for joining us for our webinar. This month we are pleased to have our own Dr. Kate Clark and Dr. Sam Rosalina, who are going to be talking to you today about how to navigate molecular testing. I'm sure most of you already know Kate and Sam, but as a quick introduction, Kate is the Technical Director here at Microbial Insights, and I think most of you have probably experienced the wealth of knowledge that Kate has about molecular tools. Since joining Microbial Insights in 2013, she's been responsible for project development, management, aiding clients from the selection of assays and study design all the way through reporting and result interpretation. Kate received her bachelor's in biology from Rhodes College and went on to complete her PhD in chemical engineering from the University of Tulsa. And during her PhD studies, Kate really focused on the use of molecular tools, including qPCR and stable isotope probing, to assess bioremediation of petroleum, hydrocarbons, and fuel oxygenates. So she's a real expert in helping you pick the different tools that can really aid you in your site management. And then we have Dr. Sam Rosalina. Sam optimizes and implements the new analysis in our stable isotope facility. And I'm sure many of you have talked to him, and he has an incredible wealth of knowledge about different CSIA techniques. His expertise and experience in the development of the cutting-edge analytical techniques ensures that our lab here has the highest standards of accuracy and precision, while he continues to broaden the scope of molecular diagnostics that we can use for environmental and corrosion assessment. Sam received his bachelor's in chemistry from Berea College and went on to complete his PhD in analytical chemistry at the University of Tennessee. Throughout his PhD research, Sam focused on the analysis of trace-level environmental toxins, including heavy metals and toxic gases, detection and quantification of trace contaminants and complex mixtures and medias is an especially challenging field that requires not only the development and optimization of innovative new tools, but also rigorous QA/QC. So Sam has done a great job of that in our CSIA facility here. During the talk today, Kate and Sam are going to walk you through step-by-step your molecular testing, starting with assay selection and sample collection all the way to result interpretation. And they're going to cover a lot of the topics and questions that you guys commonly ask us. So I think you're going to be hearing a really great basic level introduction to molecular biology for you today. So many of you who have attended our webinars before know that it will be recorded, and it's going to be available on the resource section of the Microbial Insights website within the next week. There's no need to email us. A link is going to be sent to all registrants as soon as it's available, and then it'll be available on our website for you. So at the end of the morning's webinar, there's going to be a question and answer period. So please go ahead and type your questions into the GoToWebinar software, and Kate and Sam will be glad to answer them for you at the end of the presentation. If you think of additional questions or you need additional information, you can also email us at info@microbe.com, and we'll be glad to help you with any of those. So I will go ahead and turn it over to you guys. I think Sam is the first speaker, so I'll turn it over to you, Sam.
Thank you, Dora. Hello, everyone. As Dora mentioned, my name is Sam Rosalina. I'm the CSIA Laboratory Director here at Microbial Insights. You'll have to excuse me today. I am at the beginning stages of a cold, which is bad news for me, but good news for you because I have a nice low narrator's voice today. So hopefully that makes things a little easier to work with. But please excuse me if I have a sniffle or clear my throat through the presentation. So as Dora mentioned, today we're going to be talking about how to navigate testing that we offer here at Microbial Insights. We're going to start from beginning to end, between thinking about which tests to utilize and then determining what the results mean in those tests as well. So I wanted to start by mentioning that this year at Microbial Insights, our theme, both internally and externally, is crossroads. And when we think about crossroads, we're thinking about both paths diverging and merging as well. So when we're talking about environmental remediation or corrosion analysis, when we're talking about paths diverging, we want to think about the ways that the directions we might take a project from this point in time. So for example, if we're at a stage within a project at a site, then we want to say, okay, what lessons do I need to learn? Which direction should I go next? Which analysis should I take? and which stage should I go to. But when we're talking about merging pathways, we're also thinking about the way that multiple lines of evidence should come together and meeting all of those lines of evidence at one place in the middle to determine, again, which place to go next. So you'll be hearing us talk a lot about that this year. And specifically, I think this is a great idea for this specific webinar for the beginning of the year, is thinking about how assay selection might help us determine which direction to go next at a site, and the way that we might interpret results is important for thinking about that crossroads, multiple lines of evidence. So I'm going to start today with an overview of what we're talking about. We're going to be talking about, again, assay selection. So which tool do we want to move forward with? Which tool is best for answering questions at our site? And then we're moving into a very important process, which Kate is going to cover for you, which is sampling strategies. So the best locations to sample, the best ways to sample for a given assay that you've selected. And then we're going to move on to data interpretation. So not only do we get this data, but what do we do with it next to determine which direction to go at our crossroads? So I'm going to start with some assay selection options here. Now, we have a number of tools for a number of different markets, and in fact, on our new website, you can see a list of some of the markets that we offer. Now, many of you know about our remediation and our microbiologically influenced corrosion fields that we offer tools for. But there are a number of other industries that we also support, things from biofuels to wastewater treatment to microbial source tracking, and even unlisted here in this list. If you ever get a chance to talk to our president, Dora Taggart, about times that we have analyzed moon rocks, for example, for NASA, or the time that we analyzed samples from King Tut's tomb. So we kind of cover a lot of different markets and fields, and we find that this helps us in microbiologically understanding of what we do here, because we can look at these things from a lot of different viewpoints. We also offer a number of tools. Again, there are a number of webinars that we've provided about each of these tools in particular, so we're not going to go into too much detail about these specific tools. But there are a number of things that we offer. Many of you know kind of our flagship analyses, which are quantitative PCR and quant-array. We also offer a number of isotopic analyses, larger, broader look at genes, and specifically looking at taxonomic genes for next-generation sequencing. So we're also constantly, because we've moved on over the past 30 years looking and using these tools, we're constantly fine-tuning them and adding to this list with a lot of research and development in mind. So you'll see this list of tools grow over time. And we're always kind of keeping in mind what you need to answer questions at your site or for your project. So again, we've been doing this for 3 decades now. We have a lot of experience in these specific tools. And there are a lot of answers that we can gather from the data that is provided by these tools. So for example, if we want to know biological potential, we turn to qPCR or quant-array, where we're looking at many gene targets at once. Or if we want to prove contaminant degradation, we can either turn to stable isotope probing if we're looking at petroleum hydrocarbons at a site. Stable isotope probing will give you a direct proof that a contaminant is being degraded and utilized for either growth or energy at a site. Or if you're dealing with a chlorinated solvent plume, you can turn to compound-specific isotope analysis. It's another great way to prove that degradation is actively occurring. And then finally, we also offer a number of different testings for sites. So for example, we have in situ microcosms where you can test a number of different amendments from different vendors and see what works best at your site. So as far as assay selection goes, how can our website help? So you may have noticed, and as I mentioned previously, we have kind of a new improved website that we're very excited about this year. It gives a lot of offerings as far as resources go, but hopefully as the overall layout is seen, it's more useful than it ever has been. So, for example, you can search by analysis or industry or contaminant. So if you have a specific contaminant in mind, or if you're curious what offerings we have for wastewater treatment, for example, then you can search based on the headings of our website there. You can also download fact sheets and white papers specific to each of these tools. So under a specific tool on the website, there will be links below it that offer different white papers or fact sheets that you can download. And then also we have a number of other resources like recorded webinars. So for example, today's webinar will be up later and you'll be able to watch it again in the future. But all of the webinars that we've performed and had experts come and provide for us on this website, through this website, have been recorded and saved within our archive. So you can go back and watch specific webinars about a tool that you might have questions about. You can also contact Microbial Insights for a quote specific to the assays that you are interested in. So this is another way that you can utilize our website for help in this stage of the process. So again, if you're unsure of what step to take next, our website, microbe.com, is a great resource for determining what makes sense for your site. Something else that we offer that is newer is when you search for services by contaminant, it will give you a long list of different contaminant options and then those individual analyses that are available for those contaminants. So based on what type of situation you expect your site is going through, whether you expect anaerobic biodegradation, for example, for chlorinated solvents, or you're expecting aerobic metabolism occurring for petroleum hydrocarbons, then there will be a list of analyses that make sense to look at next to that. But also, as you'll see here in this screenshot from our website, there are now packages that are available. So under chlorinated ethenes, for example, we have 3 different options for packages. That is biodegradation, M&A, and abiotic packages. And what those look like, if you click on those links, is what you'll see are that we've combined complementary analyses specific to those situations. So again, if you're interested in concentrations of contaminant-degrading microorganisms related to chlorinated ethenes, then you might look at package 1 or 2. You might want to know whether the contaminant degradation has occurred, and you'll notice that in both of these packages, CSIA is listed. So what we've done is we've kind of given these options as ways for understanding different complementary analyses that can occur together. So now you can order packages through us. What about, so this is an example for biodegradation, but what about monitor natural attenuation? We have different packages related to that might include aerobic cometabolism or abiotic degradation of chlorinated ethenes. And then we also have specifically abiotic packages as well. So we're looking at different analyses that are complementary to those situations. This kind of falls in line with, the thing that we commonly preach at Microbial Insights, which is looking at multiple lines of evidence. So once you've seen your geochem data and once you've seen your VOC data and you know the history of your site, you might have a better idea of which of these packages would work best for your site. So for example, if you happen to believe that there might be some iron present at your site, you might look at some of these abiotic packages to see what might be occurring in the subsurface of your site. We also have different packages. I just listed chlorinated solvents as an example. Of course, we have petroleum hydrocarbons as well, but we also have different packages for certain one-off kind of compounds. So for example, 1,4-dioxane, we have a package available for that. Again, complementary analyses for the analysis of 1,4-D degradation and cometabolism. So all of that kind of sets up for our next stage. The next stage, of course, is the sampling strategy. And all of these individual things from assay selection to sampling strategy, all the way down to data interpretation, are very important to keep in mind in the beginning of stages of determining what to do next. So I'm going to pass the mic over to Kate. Kate, as many of you know, is our amazing technical director here at Microbial Insights. She's going to talk you through different forms of sampling strategy and how to move forward with your project on that front. So here's Kate.
Okay, thank you, Sam. So once you're ready to move forward with an analysis, it makes sense to devote some time to planning your sampling strategy. So this can mean thinking ahead about how you plan to use the results and making sure that you're collecting enough samples from the right locations to aid your interpretation so you'll be able to draw some strong conclusions. This could also include some very practical concerns about what supplies and equipment you'll need at the site and how often you should plan on shipping samples back to the lab. So one of the first things you'll want to decide is the sample matrix. Most of the analyses we offer can be performed on a wide variety of matrices. Liquid samples can include ground and surface waters, as well as solutions flowing through a pipeline or industrial system. We can look at the microbial community in soils as well as solids. This could be GAC from a filtration system, sludge, maybe if there's a biofouling issue, or a scraping of corrosion products. To collect a time-integrated sample, biotraps can be deployed in water or soil for about a month to sample the active members of the microbial community. And although compound-specific isotope analysis is the most commonly performed from water samples, air samples can be submitted when using this technique for vapor intrusion applications. For quantity and qPCR analysis for environmental remediation applications, groundwater samples can either be collected in 1-liter poly bottles or using bioflow filters, which can be connected to a pump at the site. The bioflow filters are recommended for low flow sampling and low turbidity samples, as they're lightweight for shipping purposes. But both methods yield equivalent results, and there's no extra charge for either type of supply, so it's really just your preference. We also offer a passive sampling tool called a biotrap sampler, which is a replacement for collecting groundwater at your site. The biotrap is a unique and patented technology that was designed by the University of Tulsa and DuPont, and it's a way we can collect microorganisms so we can understand biodegradation potential. The biotrap contains bioset beads, which are composed of 75% powdered activated carbon and 25% Nomex. Nomex is the same material used in fire retardant suits, so it allows us to heat these to very high temperatures, ensuring that they're sterile prior to deployment. The biotraps can be used in conjunction with all of the molecular analyses that we offer, and in fact, stable isotope probing and in situ microcosm studies can only be completed using biotraps. So there are a few things to consider when deciding whether to collect a grab sample of water or an integrated sample using a biotrap. For a water sample, you can collect a sample and ship it to the lab the same day, so there's only one site visit required, and for most analyses, you'll have results within 1 to 2 weeks. For chlorinated solvent sites where dihelicocoides is of interest, water samples have some additional benefits. With water samples, we can filter them to concentrate the biomass and achieve lower detection limits. So since dihelicocoides is non-modal and slow-growing, when dihelicocoides concentrations are low in a water sample, they may be below the detection limit in a biotrap. Also, if you want to be able to compare your results to literature values, such as this threshold concentration of dihelicocoides that's associated with effective rates of complete reductive dechlorination, much of that work is based on groundwater samples, which are reported in units of cells per milliliter, whereas biotrap data is reported in units of cells per bead, and the two are not directly comparable. On the other hand, biotraps work very well for sampling at hydrocarbon sites. Since hydrocarbon-degrading bacteria are fairly ubiquitous in the subsurface, a groundwater sample is likely to indicate that degraders are present. However, they may not be active under current conditions. But since microorganisms have to actively colonize and grow and reproduce within a biotrap in order to be detected, biotrap results increase confidence that not only are the degraders present, but they're also active. And biotraps also allow us to perform some unique testing with amendments in situ. They can be amended with a remedial substrate to assess its effectiveness prior to injection, or with a carbon-13 labeled compound to demonstrate that the contaminant is biodegrading under current site conditions. And I want to share some general guidelines for microbial sample selection for remediation. We would recommend to sample in the source area as well as sample a cross-section of wells down gradient of the plume. A background sample from an unimpacted location up gradient would provide an important point of comparison. And this is really important for petroleum hydrocarbon sites, where, as I mentioned, the bacteria are more common. For larger sites, you may also want to have some secondary locations, including sampling the margins of the plume. Compound-specific isotope analysis can be a useful tool to demonstrate degradation or to aid in distinguishing between multiple sources. In either case, 4 HCl-preserved 40 ml vials are needed per isotope. If you're looking to use this analysis to determine if a contaminant is degrading, we recommend to sample the source area as well as following the flow path down to the toe of the plume to provide a spatial comparison. If you want to continue collecting data for a temporal comparison, we recommend to continue monitoring the same wells every 6 months. When using compound-specific isotope analysis for source distinction purposes, 2 isotopes are always recommended. So for chlorinated solvents, we would recommend looking at both the carbon and chlorine isotopes. You want to sample multiple locations of the plume in question, along with every possible source, collecting at least 3 samples along the flow path between each source area and the plume in question. For microbiologically influenced corrosion applications, we can perform the DNA-based analyses from a liquid sample or directly from a swab or scraping of corrosion products that have collected on the surface of a pipe or a coupon, for example. It's helpful for interpretation purposes to also collect a sample from an area exhibiting no signs of corrosion as a point of comparison. If you want to establish operating parameters that could trigger some mitigation action, for example, like pigging or a biocide application, it's important to establish a baseline microbial community and to start trending that data over time. Because with this type of corrosion, the concentrations of microbial groups that could be problematic and cause corrosion issues can vary widely by system. So you want to be sure that your system is very well characterized. We also offer microbial source tracking qPCR assays. We have markers for humanates, ruminants, dogs, gulls, and geese that can help identify sources of fecal contamination and guide corrective actions to improve water quality. Source tracking samples can consist of 1 liter of surface water or a 4-ounce jar or Whirlpack bag for soil or solid samples. And Sam mentioned our website earlier, and I wanted to highlight that it has lots of helpful information related to sampling. You can download sampling protocols as well as the chain of custody. We also have videos demonstrating sampling techniques, such as deploying standard biotraps along with more advanced in situ microcosm units. We also have a demonstration of the bioflow filters. And we have some guidance on some special shipping scenarios, like sending samples from international or remote locations, or delivering samples to the lab on Saturdays. We do accept and process samples on Saturdays so that the short hold time is met, but we have a different delivery address, so we can go pick up the samples from our local FedEx first thing that morning, and there's no delay in starting the extractions. One new addition to the website that we're really excited to introduce is an online supply ordering feature. You can place your supply orders online, and as always, the supplies are provided for no additional cost. You'll be able to easily duplicate past orders, which can be very helpful for sites undergoing routine monitoring. I've included the link at the bottom of this slide, but it's also very easy to navigate to from the home page of the website. I wanted to briefly mention sample preservation and shipping because there's a short hold time for these DNA-based analyses of 24 to 48 hours. So samples should be shipped to the lab overnight on plenty of ice. The lab will perform the DNA extraction immediately upon arrival, and the results are rapid. For the qPCR analysis, it's 7 to 10 days, and quantity is 1 to 2 weeks. We routinely receive samples from all over the world. We've gotten samples from all 50 states and 37 different countries. So we have labs in Australia, 2 in Europe, and there are shipping locations in China and Canada. that can help facilitate your needs. So wherever you are in the world where the samples are being collected, there's an easy way to get them to our lab for the analysis. Now I'm going to share some approaches for data interpretation that I hope you'll find to be sensible and accessible. I want to encourage you that you don't have to be a microbiologist to start making sense of your microbial results. As Sam mentioned, at Microbial Insights, we always advocate a multiple lines of evidence approach, integrating your microbial results with site chemistry and geochemistry in order to see the big picture of what's going on at the site. So when you come to a crossroads on a project and you need to decide how to proceed, we always recommend to base your decision on multiple lines of evidence, evaluating the microbial data within the larger context of what you know about the issue at your site. So for remediation, that would mean looking at trends in contaminant concentrations and daughter product formation, along with the geochemistry, examining the prevailing redox conditions. For corrosion, you'd want to take into account the system as a whole, the metallurgy, any coatings on that, as well as the operating conditions, temperature, pressure, pH, flow rate, etc. There may be corrosive gases or process chemicals that could also be contributing to the issue. And now I want to go over some specific strategies for interpreting qPCR and quantity data. And the first is to highlight the benefits of having a background sample or a baseline sample, which can provide additional context to your site. For a background sample, I'm referring to a sample from an unimpacted area, so we can compare how the selective pressure of the contamination has impacted the microbial populations. Baseline samples are taken before a given treatment to understand the response of the microbial community to the activities taken at the site. For instance, this is a site as a petroleum tank farm where there's been historical releases of crude oil and petroleum condensate. BTEX was a primary concern due to its greater mobility, and this slide shows qPCR results from some known aerobic BTEX degradation genes. MW7 was an unimpacted background location, and we can see the functional gene concentrations in the impacted wells, MW2 and MW6, were orders of magnitude greater compared to MW7. When we're interpreting these results, we can see that the selective pressure of the BTEX stimulated microorganisms with the genetic potential to aerobically degrade that BTEX. And here's an example of baseline comparison at a site contaminated with chlorinated solvents. The site was being stimulated by electron donor addition, and we can use qPCR techniques to monitor the microbial populations to be sure that we're stimulating the organisms of interest. As you can see in the graph, Dihelicocoides is detected prior to injection, but at very low concentration. Post-stimulation, Dihelicocoides and functional genes have increased by orders of magnitude and are about at that 10 to the 4 cells per milliliter mark, that we know is important for efficient degradation of chlorinated solvents. We also see from continued monitoring that Dihelicocoides is still stimulated even 18 months post-injection, and therefore there's not a need to add additional electron donor at this time. And here's an example of the same concept of baseline and post-treatment samples, but for a corrosion application. This was a biocide screening study for a produced water tank where a coupon was submitted for qPCR analysis prior to the biocide treatment and then again after the treatment. You can see from the results on the right that the total bacteria and archaea were very similar at both time points, and the biocide had no effect on the sulfate reducers and methanogens that were in the system. Based on these results, it was concluded that the biocide treatment was ineffective. This was likely because it could not penetrate the established biofilm in the tank. Another interpretation strategy is to compare our qPCR results to threshold concentrations, which have been determined for a particular organism or gene. And this is particularly important with Dihelicocoides. Dihelicocoides is known to completely reject lead to chlorinate chlorinated solvents. However, low concentrations of the organism will likely not yield the degradation effects that we hope to see. And this is an example of a portion of the quaternary chlor data related to reductive dechlorination. In this example, we see that the helicocoides is detected, which is good, but it's at low concentrations. We know from analyzing more than 13,000 helicocoides samples that if we have 10 to the 4 cells per milliliter of helicocoides or greater, we have an 80% chance of seeing ethene formation at our sites. So this is our target mark to hit. And if we do the analysis and get very low concentrations like we see here, then we probably want to take further remedial action to stimulate these microbes. Now going back to the post-injection slide from before, we can see that we can add some type of electron donor to stimulate the helicocoides and achieve those concentrations that are around that 10 to the 4 cells per milliliter mark. Now I'm going to turn it back over to Sam so he can share the final interpretation strategy with you using Microbial Insights databases.
Thank you, Kate. So as Kate mentioned, specifically with sampling strategies, we're always kind of looking at trends. And when we're talking about qPCR quant-array data, when we're talking about DNA analysis, a lot of that trending is comparing backgrounds or baseline samples, so pre or post-treatment, or background unimpacted wells versus impacted wells or pipelines. And so we want to take those into account when we're doing interpretation. We also want to compare those threshold concentrations that we do know about. So again, for DHC, we know that 10 to the 4 cells per milliliter is a very important kind of magic number where we see 80% chance of complete reductive dechlorination at a site. But for some others where we don't necessarily have those threshold concentrations, there can be some difficulty in just looking at a number that is provided on a report and determining whether it's a good number. So this is when Microbial Insights database comes into play. So the question always is, and this is a very common and understandable question, is this a low, medium, or high number? And so what our database can actually do is retrieve percentile rankings for your DNA results and determine, based on samples collected and analyzed from around the world, whether this is a high, low, or medium number. And so a little bit about our database. As many of you are familiar, one of the unique things about Microbial Insights is that we've been working on this database for over 20 years. And that includes over 120 different gene targets and 45,000 different field samples. We're coming from all 50 states and over 33 countries and 6 continents. So what that means is that we've collected all this data into one location. And so you can actually bounce your numbers off of this database to determine, is it a high, medium, or low concentration? And so again, the question would be, I got this number on my report. What does it mean? And so compared to those 45,000 different field samples, you can pull up those percentile rankings and determine this is an okay number, but maybe I need to do another injection, or maybe I need to add another biocide to determine if that number drops or increases in the case of environmental remediation sites. Or you might find that after an injection that the numbers have reached some of the higher percentile rankings compared to sites from around the world, and you then have direct evidence that your injection was effective and working the way that you hoped it would be. So that's what comes down to DNA analysis for our database, but what about some of the other assays that we offer, some of the other tools and techniques? I'm very excited about this, and this has been mentioned in a previous webinar, but Microbial Insights now has a compound-specific isotope analysis database, and this is one that we've been working on for quite a while now. So this has many different features and techniques that I'll run through here in a second, but some of the most important things is that it has over 500 different CSIA literature values in one location. So this is useful to many of you who know that CSIA the data on its own can be helpful, but when you have the context of literature values and published information, then it can be that much more useful. And so what we're looking at now is, instead of having to search out for all of these individual values yourself, and then finding many times that they're behind different paywalls in order to get the literature that would require to see these values, what we've done is we've compiled them all for you in one location. And the reason we want to do this is we want to make this CSIA data more accessible. We want it to be more useful for you and your site. Another important thing that we're doing here is automatically plotting the data that we provide to you after you've run CSIA through our labs. And what that looks like is plotting those values in different ways that allows for easier data visualization and easier data interpretation. So what this looks like, and many of you who have run CSIA with us over the past 6 months will have gotten a link in your email for your final report. So make sure you check that out if you haven't yet. What this looks like is you log into the CSIA database. You have your project numbers up at the top that you can choose from that you've run through us over the past. And what it provides to you is, up top, you'll see 3 different tabs. There's tables, plots, and then an interpretation example. So when we're talking about tables, this comes down to the raw values from literature. So we have a few different things. The first thing that pops up, and one of the things that people are most interested in, are the manufactured ranges of different compounds. So what this means is the delta values of specific compounds when they're pure and undegraded straight from the factory. And I'm not going to get into too much detail, but this is very important if you're doing a first-time analysis, you don't have any previous CSIA data to compare to, and you want to prove that a contaminant is degrading. You can instead you can compare your data value that came back in the report to literature values of manufactured ranges to see if it's increased. If it's increased compared to the manufactured range, then you have direct proof that a contaminant is degrading. And so we have these ranges summarized for you in a very simple table for the compounds and isotopes of interest that you chose for your specific project. Another important thing is something called an enrichment factor. The enrichment factor can provide a lot of information about what type of degradation your compound might be undergoing. So again, we have a very simple summarized table for that below the first table, and that includes all of the compounds and isotopes of interest that you have. Again, all of this has been compiled for you, so you don't have to go out into the Ethernet and determine what these values are yourself. Now below those, we have more detailed tables. So these are the same values, but it gives you a little more information and actually gives you the references that you might need for a report or for looking into the research yourself. And more importantly, this will give you information about whether, for example, in the enrichment factor table, whether this value comes from biotic or abiotic degradation, whether it comes from a specific type of organism or a specific type of abiotic compound, for example, ZVI or sulfonated ZVI. And we have a very similar thing with the manufactured range reference table as well. So again, all of those values that you might be interested in, but a little more detail if you wanted those. And that includes the actual reference to the original papers themselves. This is on the first tab of that CSIA database, but possibly the most helpful, I believe, tab present is the visualization of the data that you received back from us, including the visualization of those same literature value tables. So this starts with mole fractions that we would enter based on the VOC data that you've provided to us. And these alone, as many of you are already very aware, can be very useful for determining whether something might be degrading, whether background wells look very different from wells where you expect degradation to occur, or wells where you expect that degradation is stalling, for example. So visualization is extremely important for determining next steps at that crossroads. And then we come to some of our first plots of the actual data that came from the isotopic analysis. So this, for example, is a 13C plot for PCE that was run through our lab. And what we're looking at here is a number of things. So first of all, we have each of these samples, which are provided in different colors and shapes so that we can easily differentiate them. But just as Kate mentioned, when we're sampling, and this applies to CSIA as well, we want to sample down the center line of a plume. So what we're seeing here is as groundwater was pulled from either the beginning of the plume or near the tail end of the plume, we're seeing that these delta values have increased, which shows that degradation is occurring. Now, this pink stretch here is something called, this is the manufactured range that we mentioned before, but it's actually being visualized instead of just values. And so we can then compare our data to that manufactured range as well. And you choose that manufactured range based on the original parent compound. So above this plot on our database website, you'll see that you can choose the parent compound. And then you can also choose which compound to plot. And so this would give you this specific information. You can also add on a 2% uncertainty, 2 per mil uncertainty, which is direct from the EPA guidance document. That 2 per mil uncertainty value is based on the standard error of carbon analysis through CSIA. You can read more about that in the EPA document or find my other CSIA webinars that are on our website and learn more about that. But this gives us kind of an error to compare to as well, to keep in mind the context of standard error. Another important function is if you're running more than one isotope for CSIA, what that looks like is plotting that in dual isotope plots. So if we look at this dual isotope plot, we're plotting the delta value for carbon against the delta value for chlorine. And this can come in handy for many ways. It can show both degradation based on this pink manufactured range box. If the data points are moving outside of that box, then we have indication of degradation, and if they move far enough outside of that box, then we have direct proof of degradation. But we can also see in this example that there are 2 different linear trends occurring. So we can utilize that information to say, this looks like 2 different sources that are occurring within these wells. So if we see 2 obviously different linear trends, or we see different groupings of data points in CSIA, we can use that to investigate further whether there is a difference in sources. So it's very useful for source delineation in that way. And then finally, we have a plot that we've named the modified Cooter plot, which is a nod to our friend Tomas Cooter over at Oklahoma. And what this does is we can, again, I won't get into the details, but we can plot essentially the natural logarithm of the mole fraction of whatever compound we're interested in against the delta value of that same compound. And this can give us information. Essentially what it means is that the slope of these linear trends are the enrichment factor, and that can give us information about whether the degradation mechanism is most likely biotic, which is this blue range, or abiotic, which is this pink range. So as you see, trending the data is very important, as Kate already mentioned. And in this trend, we see a linear trend that is following the biotic range as opposed to the abiotic range. So it's important to sample all the way down the center line of that plume. And then finally, the last tab in the CSIA database is the interpretation example. This runs you through an example site and helps you kind of learn more about each of these plots and determine the best ways to utilize them for information to determine what to do next at your site. So when it comes down to interpretation, we have a lot of different resources. We, again, want to look at different trends and comparisons within our data, and that goes back all the way to the sampling strategy, determining background versus impacted, baseline versus post-treatment, and then trends over time, for example. We also have our MI databases that we've put a lot of time and care into to help you out more, and those databases include both real-world field samples as well as literature values in the case of CSIA. But on top of this, we also have a number of additional resources, different reports that we offer, interpretation sections of the reports themselves. Then, of course, our website, aside from the actual resource links have a lot of information within them that explain what each of our gene targets is and different ways to utilize the data that's given to you. So overall, our main tips for success are to learn about the analytical tools and determine which assay is best for your site, which questions are you trying to answer at your site, and then based on that, plan your sampling strategy. And as we've already seen, the sampling strategy is directly tied to the actionable data that comes from that. So you want to make sure that your sampling strategy includes the type of trends that would help you answer questions that you have now, but that can also help you answer questions that you have in the future. And then add context using Microbial Insights resources like our databases and our white papers that we have on our website, or our explanations in our reports, or more detailed comprehensive reports, for example. So the last thing that I want to mention is that we've been around for 30 years. And we've taken these tools that were originally developed by Dr. White, and we've added on to them, and we've fine-tuned them, and we've increased our knowledge of the utilization of these tools so that we can help pass that information on to you as well. We have a lot of different experience in this, and this is one of the few companies I think that you'll find where the people who are speaking to you on the phone, people like myself and Kate Clark and Casey Brown, who is the DNA laboratory director, are experts in our field, and we're happy to talk to you about that. And one thing that I want to mention is that we do this for a number of reasons. There's a reason that we have 100% on our evaluations for customer service. And that's because we want to help you out in solving these problems as well. Because at the end of the day, this is also our planet, and this is our children's planet and their children's planet. So it's important to us, not just from a technical standpoint, but from a very personal standpoint, that we can aid you in cleaning up a contaminated site as efficiently as possible, or we can aid you in catching possible corrosion in a pipeline as quickly as possible, or we can aid you in tracking microbes that may be harmful in surface waters as quickly as possible. So we're here to help, and we do that from a technical standpoint, and from a personal standpoint, we're always ready to take your calls and answer your emails and help you in any way that you need as far as data interpretation goes. But this is why we've put so much time and love into a lot of the things that we offer on our new website and through our databases. So with that, I would love to thank you all for tuning in today. And I think we have a few minutes for questions from Dora. So if Dora wants to give us some of those, then Kate and I will answer those for you. Thank you all.
All right. Thank you, Sam and Kate, for the excellent presentation. Again, if you have questions related to anything about Microbial Insights or the presentation that Sam and Kate just did, please enter those into the GoToWebinar software, and we will be glad to answer them for you. So, Sam, one of the questions that we have, it says, it's specifically for you, it's talking about CSIA, and it says, does the delta value increase with abiotic degradation too? So I think it might be good if you can talk a little bit about how we can differentiate biotic from abiotic degradation.
Yeah, absolutely. That is a great question. Yes, anytime degradation is occurring, then we see a delta value increase over time or down gradient. And so this is important because it allows us to look beyond just biodegradation at a site. We want to know if something is degrading or if it's not degrading. Now, the way that we can differentiate abiotic versus biotic degradation goes back to that same enrichment factor that I mentioned. And so without going into too technical of a detail, essentially what we're doing is determining how quickly does that delta value change in comparison to the actual degradation of the compound. So between the compound turning into a daughter product or being metabolized in the case of petroleum hydrocarbons, we want to see, does that delta value change very quickly? Is it a sharp trend or is it a slower, lower trend? And the enrichment factor, it's important to note, doesn't have anything to do with rate. Just because we have a low enrichment factor does not mean that we have a slow degradation process. But what it does mean is that the mechanism by which those bonds are broken is changing in a different way. And so that's essentially what we're analyzing when we look at the modified Kuder plot, or when we look at enrichment factors, is looking at what type of degradation mechanism is occurring. So with that said, there is more information on some previous CSIA webinars that I recommend, or you can always shoot me an email if you have specific questions in mind.
Great. Thank you very much, Sam. So, Kate, question for you. Can you talk a little bit about how people can gain access to the database?
Sure, yes. With every census or quantity report that's sent out, in the body of the email is a passcode to access the database for your specific results. The same goes for your CSIA results. There's also information on connecting to the CSIA database in the body of the email for your CSIA report. If you want to look for the percentile rankings or access to the database for an old report that was sent out before the database was created, you can just email me or Sam, and we can send you that passcode and access information for older projects.
Okay. All right. Sam, we have a chlorinated solvent site where it appears biodegradation is stalling at CIS. What tests could we do to determine if there are any amendments that would help to degrade the CVOCs to ethene or ethane?
Yeah, so one of the things that I very briefly mentioned here is something called an in situ microcosm. It's something that we offer that is also unique to Microbial Insights, but it's a passive sampling device. It's very similar to a BioTraps, but it's more advanced. And essentially what we can do is determine which products you would like to test, as far as if you wanted to look at different types of emulsified vegetable oils or from different vendors, or some other type of electron donor to help stimulate that microbiology that's occurring. Then we can prep those for you and send them to you. And then you put those in your pre-existing monitoring wells at your site in specific locations that you're interested in. And what we'll do is you'll leave it there for a period of time, pull it back up, send it to us, and through those microcosms, we'll be able to determine, compared to a control microcosm, whether the microbiology has changed with those different products that you've tested, or whether the CVOC has changed, the geochem has changed. So it's a really great way to look and compare different products without having to do full-scale pilot studies. So I highly recommend looking into the in situ microcosms to do that. That being said, it's also important to, again, trend data. So if you were curious about whether something was stalling at a site, if your CVOCs are stalling, then obviously you'll see that in your chemical data that's trended. But you might also see that in your CSIA data if you're seeing those delta values kind of stay the same year after year or month after month. And very similarly with the microbiology as well. If you're seeing the helicocoides dropping or stalling, then that can be useful to you as well. So again, trending data, and then look into those in situ microcosms. They're extremely helpful for determining which direction to go next.
Okay. Kate, question for you. With the biotraps, there's a lot of talk about PFAS, and we know that Nomex is a material that's used in fire retardant suits. Have we looked at anything about PFAS detection issues when we're using biotraps?
Yes, the biotraps do not contain any PFAS perfluorinated compounds.
Yeah, so we've done a lot of testing with that and made sure that there's no leaching of anything from the biotraps themselves, and in particularly looking at any of the polyfluorinated compounds. None of them are leached from the biotraps or contained within the biotraps. So that's kind of misspeak when people talk about that in relationships to the use of the Nomex material. And if you have questions about that, you can contact us and we can put you in touch with Dr. Carey Sublette, who developed the biotraps and has done a lot of testing on this, and he can kind of alleviate any concerns that you have about that. Okay, last question for you guys. So this one says, thanks for the presentation. It is very technical. Do you guys have any evidence with nitrogen or using nitrate isotopes to help differentiate fertilizers versus amines versus other signals? Apparently this is very hard to do, and this person is in Alberta, Canada, and they are very interested in these technologies. I'm curious to see if that can be used for the nitrates as well as the chloride. So Sam, can you talk about that a little bit and the isotopic signatures?
Yeah, absolutely. So we don't offer nitrogen analysis at Microbial Insights. It's a pretty rare isotope to analyze when it comes to the fields and industries that we work in. That being said, it's something that we're always kind of looking into. But I am happy to, if you will, my email is up on the website if you want to, or up on the webinar. If you want to shoot me an email, I'm happy to put you in touch with some labs that I think might be able to do that. That being said, it is exactly as you are thinking. It's a great way, using isotope analysis is a great way to kind of differentiate different products and where they begin, whether they're natural or synthesized, or whether they are one compound versus another. So that is a great place to start. It's just not something that we currently offer at this time.
Great. All right, thank you very much, Sam and Kate. Again, you can see that both Sam and Kate are excellent resources for you if you have any questions. We're always happy to help you on any of the molecular techniques, and if it's something that we don't do in-house, direct you to the correct labs that we've worked with that might be a good fit for you, as Sam just mentioned. So always feel free to reach out to us. We want to be that resource for you. Again, thank you very much for your time. We know your time is valuable, and we appreciate you being here. And Sam and Kate, thank you for taking time to do this webinar for us today. But I look forward to our upcoming webinar, and you will be seeing more information coming out about the next webinar that will be held in March. So again, thank you everyone else, and thank you Sam and Kate for being here today.
Thanks, Dora. Thanks everyone for tuning in.